Hi, everybody. I wanted to give you a review of the vocabulary that we've done on our algebra unit so far, okay? So here I have an equation. Okay, an equation is different from an expression because it's got this guy right here, right? You have your equation. You've got an equal sign. That means that whatever is on this side is the same as whatever is on this side. You all have been doing those Desmos activities that are talking about balance. Whatever is on this side is balanced to whatever is on this side, okay? Let's go ahead and look at our vocabulary. Here, this is called our coefficient. Sorry about my writing. I'll get better as time goes on. That's my coefficient, right? It's being multiplied by the variable. Really, really important that we know that when we have a coefficient next to a variable, that is multiplication. Here, what is this guy called? Do you remember? I hope you said variable. That is an unknown value or a changing value, right? We're not really sure what this number represents just yet. Right there, aquí, we're going to have our operator. And you can have any kind of operators, right? You can have addition, subtraction, division, multiplication. So those are all our operators. You all know about those. Here, you have your constant. That number doesn't change. It doesn't vary. It doesn't have a variable next to it, so it's constant. It doesn't change, okay? And here we have another constant, right? There's your other constant. Okay, so coefficient, variable, here's our operator, constant, equal sign, right? And our another constant. Remember that here is an expression. Sorry about my writing. I'll get better as time passes, right? And that right there is another expression. So what this is telling me is that this expression is equal to its balance with this expression on this side, okay? And all together here, the whole thing is called my equation. So really important that we know all of our vocabulary words, okay? We'll keep practicing. Be good at this. All right, so now we're going to look at one-step equations, okay? I just want you to notice that this is balanced, right? This is what your Desmos activities were all about, balance, okay? So if I'm looking at what do I see here? Well, I can see that I have 1x, and then I have 1, 2, 3, 3 units, and that it is equal to, it's balanced with 2, 4, 6, 8. Right? So I'm left with x plus 3 is equal to 8. That would be my equation. I have my variable, my constant, it's an equation. How would I solve this? How would I go about solving this? Well, what you would want to do is take away 3 of these, right? And I'll show you over here. If I take away 3 of them, 1, 2, 3, what happens? We can see that it is no longer balanced, right? So what do I have to do in order to get this balanced? Well, whatever I do to one side, I have to do to the other. And now it's balanced. So what does this tell me? It's telling me that this x is equal to 1, 2, 3, 4, 5. So the x is going to weigh 5 units. All right, so then if we're doing it algebraically, what would that look like? Notice that we'd had to do the inverse operation, right? I had to do the opposite of what is happening here. Here I'm adding, so what am I going to do? I'm going to subtract, do the inverse operation. Whatever I do to one side, I will do to the other. And what did that leave me with? Take away 3, 1, 2, 3, and I would be left with x is equal to 5. Now let's try a one-step equation with subtraction, okay? If I am trying to find the difference between these two values, I want to isolate my variable. I want to get this x all alone so I can see what the value is. Here I am taking away 9. I am subtracting 9. I'm going to apply the inverse operation. What is the opposite of subtraction? If you said addition, you would be correct, right? So I go ahead and add 9 to both sides. Whatever you do to one side, you got to do to the other. Remember, we're trying to stay balanced. Now imagine a number line where you're being asked to start at -9, and then you're being asked to move 9 spaces to the right. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, and you would end up at 0. So I would end up with x is equal to 20 plus 9, which is 29. Is that a true equation? Let's figure it out. I'm going to go ahead and substitute in 29 for my x. So 29 minus 9 is equal to 20. Is that correct? Yes. Okay, what if I have this problem right here, where I'm saying that 3 groups of x is equal to 6. 3 of x is equal to 6. No matter how you say it, we're talking about multiplication, right? So 3x is equal to 6. What should you do? Remember, we want to isolate the x, isolate. That means solito. We want to get it all alone. So we have to apply the inverse operation. Here we are multiplying. What's the opposite of multiplying? It is division. So let's divide both sides by 3. 3 divided by 3, you get 1. So that leaves me with an x. 6 divided by 3, we know that that is 2. So now I know that x is equal to 2. Okay, let's go ahead and check our answer. Substitute in your value for your variable. 3 times 2 is equal to 6. Is this true? Yes, sir. It is a true equation. Okay, now let's try this one right here. I have x divided by 2 is equal to 10. Do not be afraid of fractions, right? All that is just a division symbol. So if I'm trying to isolate my x, I have to do the opposite. If I am dividing by 2, that means I have to multiply both sides by 2. Multiply both sides by 2. 2 divided by 2 is 1. Guess what? Now my variable is isolated because we don't write 1x, right? You can just write an x. This will tell any mathematician that you've got 1x. And what is 10 times 2? Remember, whatever you do to one side, you have to do it to the other side. So that would leave me with 20. Let's see if that's true. Substitute in your value. 20 divided by 2 is equal to 10. Is this a true equation? Yes. Let's try that one again because I know it can be kind of challenging. Remember, it's just x divided by 4 is equal to 16. Okay, I want to isolate my variable, get it all alone, so I have to do the inverse operation. I have to multiply by 4. Well, whatever I do to one side, I have to do to the other side, right? So 4 divided by 4 is 1x. I have isolated my variable. 16 times 4. So let's go ahead and work that out, right? 16 times 4. 6 times 4 is 24. 4 times 1 is 4, plus 2 is 64. So now I know that 64 is equal to my x. Let's see if that's true. 64 divided by 4 is equal to 16. Is that true? You can go ahead and do some long division. Remember that? Of course you do. 4 divides into 6 one time, and times 4. You guys were doing pretty good with these, so I hope you guys remember. 6 minus 4 is 2. Bring down your 4. 4 divides into 24 6 times. 6 times 4 is 24. And your quotient is, in fact, 16. So this would be a true equation. You got it right. All right, so this one is what we call a two-step equation. Why? Because it has 2 steps. I have 5x plus 2 is equal to 12. Again, just like with the one-step equations, okay? Just have to do the inverse operation. Here, I'm adding 2. So what am I going to do? That's right. I'm going to take away 2 from both sides, right? So this is going to give me 0. I'm left with 5x is equal to, what's 12 minus 2? Well, we know that that would be 10. Once again, I want to, because I'm multiplying, I'm going to apply the inverse operation. I'm going to divide both sides by 5. Whatever you do to one side, we're going to do to the other to keep it balanced, okay? So we would be left with 5 divided by 5 leaves me an x. 10 divided by 5 is equal to 2. Let's check our answer. 5 times, do y'all remember that that means multiplication, right? Plus 2 is equal to 12. Order of operations tells me that I have to do multiplication first. So I say 5 times 2, that's 10, plus 2. Is 10 plus 2 equal to 12? Yes. All right, so that is one-step and two-step equations. Okay, I'm going to go ahead and give you a code so that you guys can hop on a game and try this out.